So let's take a look at this question about finding where two functions meet. So we want to find the values for m for which the lines y equals mx take 2 are tangents to the curve with equation y equals x squared take 4x plus 2. Now what's important here is we're deriving from some past information where we've got this quadratic that could be either way, either smiley face or sad face. And we've got a linear line that's a tangent to this quadratic. Now a tangent means that this linear line is just going to touch this quadratic like that and then continue. So it's not going to cut it twice, it's just going to have one point of intersection. Now because it's got one point of intersection, what we know about the discriminant when we go to solve this is our discriminant must be equal to 0. And that's going to be important when we're tackling this question. Now it's also important to note here that with our linear line, we've got fixed in place our y-intercept, but we don't have fixed in place our slope. So what that means is our y-intercept, it could be say here in perspective to everything, but if we've got this y-intercept fixed here, there's actually more than one line that we can draw that creates a perfect tangent. So for example, we could have a second linear line with a tangent here. So this is important just to keep in mind when we start looking at tackling this problem. Now with this problem here, to tackle it, we've got to sort of solve this like we do with simultaneous equations, where we know that it's got one point of intersection, so we want to find that point of intersection. So if I consider this to be y1 and this one up here to be y2, the situation I'm really looking for is I want to know when y1 is equal to y2, because that'll be where they intersect. Now if I substitute what y1 actually is, so that's this x squared take 4x plus 2, I can now say that's going to be equal to my y2 of mx take 2. Now when I'm solving these sort of quadratics, I want to make this equal to 0. So to do that, I'm going to subtract mx on this side and so add 2 to both sides. So this will become x squared, take 4x, subtract my mx, plus my 2, and then add another 2. And when I do that, it should now equal 0. So here, let's just clean this up by collecting like terms. So I've got x squared. I'm going to add this, but I've got negative 4 take m, so negative 4 take m, and that'll multiply by my x, and then 2 plus 2 will be 4, and that'll be equal to 0. So now what I've got is I've got this quadratic here that's equal to 0. So I can now use the quadratic formula, but more so I can use this discriminant because I know that when we do the discriminant of this, it should equal 0. So I want to know when the discriminant is equal to 0. Now, discriminant is found by going b squared minus 4ac. So our b is the coefficient of x, so that'll be this negative 4 take m all squared. And then I'm going to subtract 4 times my a, which is the coefficient of x squared, of 1, multiplied by c, which is the constant of 4. And when I do that, it should equal 0. Now let's expand this now. So negative 4 times negative 4 will be 16. Negative 4 times negative m will be plus 4m. Double that will be plus 8m. The negative m times itself will be plus m squared. Negative 4 times 1 will be negative 4 times times 4 again will be negative 16. And when I do that, it should equal 0. Now I'm just going to collect like terms and just rearrange this. So this will be m squared plus 8m. 16 take 16 will be 0. So that will equal 0. And now what I've got is a situation where I've isolated just m. I don't have x's anymore. And I can solve for m in any way that I want. Now, given that this is a quadratic, the very first thing I should do is look to see whether I can factorize it. Now, I notice that there's a common factor of m here, so if I remove that, that'll give me m plus 8, which is equal to 0. And now I can use my null factor law, so therefore, either my m must equal 0 or the m plus 8 must equal 0. So therefore, my m must equal 0, or to make this part equal 0, it would have to be negative 8. So what that means is my two values of m that will create a slope that will create two tangents to this curve is 0 or negative 8.